Hello and welcome to this seventh video in our lecture on hash-based crypto primitives. Before we discuss the details of the algorithms of HMAC in the next videos, here I want to discuss the reasons why HMAC is so popular and discuss the motivations and design objectives for it. So over the past few years, there's been an increased interest in developing a message authentication code or MAC algorithm that uses a cryptographic hash function, such as SHA-1 or SHA-2. So here are the main motivations for this approach. First of all, cryptographic hash functions have better code execution time, or they are faster than typical encryption algorithm like DES. So they are faster to run than encryption. Second, there are existing algorithms already implemented in used cryptographic libraries such as Crypto++ and OpenSSL that already have built-in hash functions in them, and they are widely available and trusted. And the third motivation is make sure you realize that the standard hash function like SHA-2 are not designed to be used as a MAC algorithm because they only take one input, which is the message to hash. They don't allow a second input, which is the secret key that is needed for a MAC algorithm. So there is a need to develop a new algorithm that uses both a hash function, a standard hash function, and a secret key. So the most common or most popular approach that has been developed over the years is called HMAC. It has been used for quite a while. In fact, it's already built in within the standard TCP/IP networking stack. In fact, HMAC is used both at the internet layer in the IP security suite of protocols. So the secure version of IP, now called IPsec, uses HMAC, and HMAC is also used at the transport layer in the networking stack, as it's called here TLS, the transport layer security protocol, I think it's called. So if you haven't done any networking yet, don't worry about it, but just know that HMAC is not only a very popular algorithm, but it's being used every day in many packets you send around on the internet. For example, if you are using a VPN, then it's probably built on top of IPsec, which uses HMAC. So what are the design objectives of HMAC? Here is a list that was published a while back. So the first design objective is that this HMAC algorithm should be able to use existing hash functions without modifying them. Because hash functions are known to be fast and to execute quickly in software, they are widely available. We should just be able to use them as is without having to change them. Second, the HMAC algorithm should use this hash function as a simple drop-in. So every time a faster hash function is designed or a more secure hash function is designed, you should be able to just plug it into your MAC algorithm without having to change anything else to the MAC algorithm. The third objective is when we use this hash function, we want to preserve its original performance. So we want to make sure that it executes as fast or not significantly slower than the original hash function. Another objective is that since we're going to use private keys, we want to make sure we can handle those in an easy way that's not too cumbersome. And a third design objective has to do with the security properties of this HMAC algorithm. We want to make sure that we can guarantee some level of security, but since we're using a hash function as a component of that, this security is going to have to be based on the security of the hash function. So we want to be able to guarantee the security of the HMAC algorithm based on reasonable assumptions about the security of the embedded hash function. So knowing something about the security of the hash function, we should be able to infer something about the security of the HMAC algorithm that uses it. So the first two objectives are important for HMAC to be widely acceptable. So what this means is basically the hash function should be a black box from the perspective of the HMAC algorithm. And this has two benefits, as we briefly mentioned already. So the first benefit is that you should be able to use the hash function unchanged. So it's really a black box. You don't even need to know how it works. You just plug it into your HMAC algorithm. And the second reason for this black box ID is the fact that every time your hash function is broken, you should be able to replace it with a better, more secure, or even faster hash function without having to worry about changing anything else to the rest of the design of your HMAC. And then the last design objective we discussed, which is the one about the security, is also very important. And the reason HMAC was widely accepted and is widely used is because the researchers who proposed it were able to actually prove some security guarantees. And yes, the security guarantees are relative to the security of the hash function that's being used. But they were able to prove that if the hash function is secure, then the HMAC algorithm is at least as secure as those hash functions. And the fact that they were able to prove it in a rigorous way is a big reason why HMAC became so popular.